Hello, we just finished doing a video on how to add vectors with just by drawing. Now we're going to do one where we're going to actually subtract vectors by drawing. So a little bit of background is basically whenever you have a vector, if you multiply it by any number, basically as long as the number is positive, it doesn't change direction, it only changes length. So for instance, if you multiplied it by 1/2, it would get half as long, but still stay the same direction. If you multiplied it by 2, it would get twice as long, but still again stay in the same direction. If you divide it by or multiply it by a negative number, then it's going to flip directions by 180 degrees. So if it's this way initially, then it's going to be this way afterwards by multiplying it by a negative. So if you do a combination, of course, it's going to flip it and change its size. So for instance, multiplying by -1/2 would make it half as long and pointing in the opposite direction. So that'll come in handy for us to understand how to subtract. That and the definition of subtraction, which says a plus or a minus b, is actually a plus the opposite of b, and by opposite of b we mean negative b. So let me share my screen with you and show you how to subtract vectors. So I'm using the same two vectors a and b that I used in the addition problem. There's my vector a, it's black. There's my vector b, that's red. And I ask, what does the vector s, which is called the difference vector, what does the vector s equals a minus b look like? Note the definition of subtraction is a minus b is defined to be a plus the opposite of b. So one thing you want to realize, just to give you something physical to hold on to, a is called the minuend and b is called the subtrahend. So notice the subtraction goes with the subtrahend. So that's the way of thinking about it. And that just gives me a way to specify a trick that I'm going to use in a second. So remember, your vectors, you can, at least at this stage of the game, you can do anything to them you want, as long as you don't stretch them, compress them, or change the direction. So if I want to add a and b, or excuse me, if I want to subtract b from a, then I can make it into an addition of a plus the opposite of b. Well, what's the opposite of b? Well, it's b times -1. And of course, b times -1 is just b the exact same length, but with the arrow on the opposite end. So that's what I'm showing here. So now if I put a and b head to tail, where for instance I put the tail of a at the head of b, then I'm adding -b plus a, which happens to be the same thing as a plus -b. So that is the answer. Notice I draw a vector from the tail of the first vector to the head of the last. So when I put them tail to tail or head to tail, then I just go from the tail of the first to the head of the last. Similarly, if I'd done it the other way, if I'd put a down first and then put the tail of opposite of b at the head of a, then I would draw again from the first tail to the last head. And again, you get the same vector. Notice it's the same length and the same direction. In fact, I even did a copy and paste to this one, so they fit perfectly. Another thing is, if you actually have them tail to tail, it's actually really easy. Where the tail to tail was kind of a pain with adding, you had to complete a parallelogram. But with subtraction, you can do tail to tail addition just by drawing a vector starting at the head of the subtrahend, which is the b. That's why I use the whole word subtrahend and minuend, which is weird words that most people don't know. But subtrahend, you draw from the tail of the subtrahend to the head of the minuend, and you get the subtraction, or the difference vector, which is s. So you can see I labeled them all in different colors in hopes that it would help you remember what's what. So like I said, the difference is the sum, or excuse me, is the subtraction of two vectors, the answer of a subtraction problem, in other words. The minuend is the thing you're taking a number away from, and the subtrahend comes after the subtraction. So you can even look at it that way, subtraction. All right, hopefully that helps.